Part 2 of syllabus. Alright, why is Go important? You know, you gotta wonder about different programming languages. There are a lot of them. And Go was not around when I went to college. It's newer than that. It's about 10 years old now, actually. I've been using it for 7 or 8 years. When I went to college, you saw computers that had a single CPU. That was almost all computers. Occasionally, you would see really large systems with a dual CPU. Like, you know, IBM 370 systems with 2 CPUs, some high-end digital equipment corporation with 2 CPUs. But basically, when you wrote a program, it ran on a single CPU. And we had languages that were designed to reflect this architecture. And the C programming language was originally developed for a PDP 1102 with 8K of memory. And it had a disk, and when a program ran, it would take a copy of the program in memory and have another copy on disk, and you wanted to load a new program, and it would overwrite the existing program in memory with the new program, because really you only had 8K of memory. And they built a time-sharing system for multiple users on top of 8K. Which, when you think about it, that's pretty nifty. But it definitely had the context of a single CPU. One of the big advents that came along was actually a memory management unit. And the MMU allowed them to extend what they were doing to 2 banks of 32K in their very first memory management unit, but they still had a single CPU. In fact, if you look at the history of computers, this went on through about 2000, when we started seeing the common adoption of Intel chips that had originally 2 and then 4 and then 8 CPUs. And we were still programming kind of in the assumption that we had 1, which was good. All right, well, the world has changed, and we're no longer looking at things that are maybe 8 CPUs. I see that Intel and AMD are shipping 32 CPU parts. You can put 4 of these into a server. This is what you would have in a data center, an entire data center that occupied a floor back in this day and age. So that's in a single server, about this wide, by that high, by that deep. And the big change that's happening is Apple with their M1 processor. They're starting out at 8 CPUs. They've already indicated that for their higher end products, that they're going to go to 32 and 64 CPUs, and probably that they will eventually end up at 256 CPUs in a laptop. Amazon Web Services is doing the same thing with the ARM architecture, and they're going to start at 128 CPUs. And the important thing about 128 CPUs in their context is the amount of power consumption. Because the amount of power determines how much cooling you have to have. The amount of cooling depends on how many of these you can put in a box. Amazon Web Services thinks that it can put 48 chips times 128 in a single box when it starts. So with that number of CPUs, a language that really reflects running on a single CPU is a little outdated. It's not something you really want to deal with. Now, are there other languages out there that deal effectively with this? I mean, we could look at Java and threads. And there are many, many threaded applications in Java. I worked on one, which must be 4 or 5 years ago now, down in Denver, a company that had 27 servers. These were U4 servers, 27 of them, running WebSphere, IBM WebSphere, which is written in Java. And we ported that to Go. And when we got done, we had, 2 servers in Go instead of 27. And they were neither one of them was, but they were less than half loaded, both of them. We did 2 for redundancy. We didn't do 2 because we needed the capacity. It very easily could have run on 1. So going from 27 to 2, because we have a language that is well suited for high numbers of servers, is a pretty important thing. So what does Go have in it that makes this happen? There's really two pieces of technology. One of them is a thing called Go routines, which is super lightweight threads built right into the language. And if you just run a single Hello World program, you're running at least 4 Go routines, maybe as much as 10. And that's just to print out a string. So Go routines are really common. In their application, we were seeing around 6 million Go routines running concurrently. Now, WebSphere has threads. You can run about 2 times the number of CPUs. These were 8 each, so you could run 16 on each box. And that was the limit of how many you could run. So the ability to do this concurrency and concurrency management is useful. It helps you build programs that work. But the thing that made the big difference between these is they have figured out how to do an incremental garbage collector that is way, way better than everyone else's. And who's using Go? Well, Google uses it for a bunch of stuff. Cloudsphere, Netflix is a Go shop. So there are a lot of big applications out there being written in Go that use this language because it has these features, because it has this capacity. So we're going to program in Go for our first set of stuff, about half the semester. And you get to learn the language. So when we start looking at this, one of the big things we're going to cover right away is how do you learn a programming language effectively? What do you look for that gets you from I'm starting to, I can write a program in it. It may not be the best using all the features of the language, but I get some stuff done. That's one of the things we're going to look at. Now, the more mundane stuff out of the syllabus. I have office hours, Monday, Wednesday, Friday at 8, and by appointment. There are at least 10 days during the semester when I'll have something at 9 o'clock, so I won't be able to go past the end of 8 o'clock, but we can also do appointments. If you want to call me on the phone, you have to send me an SMS message so I know who you are and what class you're in, and I'll enter you into my phone book. Because if I just get a random call from somebody, chances are I will not answer it. I get 5 to 10 of them a day. There is a required text, but you don't need it right away. There is time to order it. It should be in the bookstore, or you could get it someplace else. I'm not supposed to say that, I think. I think I'm supposed to say, thou shall go to the bookstore and get it. But yes, there are other places. It's listed in here. We will have a final and a midterm. They're each worth 400 points, or 800 between the two, which means out of the 2,000 points of work in the class, most of it comes from the homework, not from the tests. I do have a late policy. It's 10% off per day until it's worth 50%. And I'm somewhat liberal in making exceptions so that if you have late work, you can still get all the credit for it. But talk to me about that in person. There are the 5 interactive discussions, and there is a schedule for those. It is in the syllabus. The first one is on February 3rd, so you have a little bit of time before we do that. All of the lectures for the class will be pre-recorded. They'll be available either for download or on YouTube. And I put the beginning of each week for when the lectures are. I will send out an announcement in the course software as to when they are available. But this gives you an approximate schedule of when we're doing things. The first homework, which is all about learning Go, is due on the, what did I put here? The 3rd of February. And it's listed in the syllabus in with the other stuff. And it's worth 100 points. Most of the homeworks are going to be worth 200 points. So that is when it is. And we will start with how blockchains work before we actually get into the grunge of this is how you deal with Go programming. The first homework assignment is out there. You can go print it out. Okay. Don't panic. None of the other assignments are like in 9 parts. This one is mostly cut and paste, run some stuff, get some output. I think there's 2 of them out of the 9 pieces that require you to write a little bit of code. But most of it is cut and paste, get this to work. The first one is Hello World. Just get a print statement. Make certain you've got the compiler installed, that you're actually working with it. And the dates for the midterm and final are in here. They will both be take-home. You will have about a week to work on them. So the dates are at best approximate, but I will announce in advance when the exact date is, when it's going to be released, and when you're going to have it for doing it. Traditionally, my midterm has been a multiple choice. Yes, you probably haven't had many multiple choice tests recently, but this one's going to be multiple choice, and we will do that one, and then the final will be some sort of a short written assignment. Okay. Now, questions that people usually have. Is there extra credit in this class? No. I seriously doubt we'll do any extra credit. I did extra credit one semester, and exactly one person that was really good did it, whipped through it, got a whole bunch of points, and then they went on mental vacation and never worked for the rest of the semester. I mean, literally. It was kind of like odd, but they got an A in the class. You know, you get an A, you're done, right? Are the tests required? If you do all the homework and get all the grades on all the homework and the midterm, you will have enough points to get an A without taking the final. So the final is required only in a perfunctory fashion, as in, send me a note with your name signed on it that, yes, you saw the final and you're done. Graduate students, you have an extra syllabus with some reading, and you will have a paper to write. It's not going to be a huge, long, formal paper. It's going to be a short paper on some subjects, but we'll have a discussion independently of the class and the rest of the students on that. And are all the lectures going to be the same length? No, we're going to take the time to cover the material and break it out in pieces on that subject. So some of the lectures are longer, some of them are shorter, but that is kind of the plan for the semester. I'm excited about this. Lots of big things are happening in the Bitcoin world and here at the university, and we have a bunch of projects that are getting funding here at the university for all sorts of stuff that's blockchain related. We have a new blockchain institute. We have a lab. There's a lot of stuff going on. And there's a good reason for that. Wyoming is really the center of blockchain in the world. We are the people that have created the laws that allow a lot of this stuff to work. We have new banks being formed in the state that are blockchain banks. We have a bunch of legislation on this. And we now have some representation in Washington, D.C. that's going to be pushing blockchain legislation at the federal level as well. So we're out in front of most other states, and there are big companies that have moved into Wyoming because of this legislation. Like IOHK and Kraken are multi-$100 million a year companies that have moved to Wyoming because of the legislation that we've passed. So this is not just a big deal in the world, this is a big deal for Wyoming too. And with that, I hope you have a wonderful day, and we will be back with the next lecture. Okay.